that the project that you're doing in Six Sigma, it is called Project Y. So suppose you are trying to improve the delivery time, right? So the delivery time would be the Project Y here, because that is a metric that you're trying to improve. And obviously delivery, you cannot have an impact on delivery time. There would be some associated factors. There would be many factors which might be leading to high delivery time. So the concept is that Y is a function of x1, x2, x3, x4, so on and so forth. So y is basically the output. You need to attack on the input on the x's which are causing the y or the higher delivery times in our example. So this is the entire concept of Six Sigma, and we will go through that practically. What is this bell curve all about? So there are two methodologies within the Six Sigma framework. So when you have a process which is already existing, you utilize a methodology called DMAC. So DMAC stands for define, measure, analyze, improve, and control. It's a 5-step methodology that we have. Most of the projects that I have done, frankly, that anybody would do would generally be, unless and until your role is that of designing the new process. So most of the project that you would generally do would be based on DMAC methodology, because this is something that is applied to the process which is already existing and needs improvement. There's another one which is called a DMA-DV, or Design for Six Sigma, which is popularly known as DFSS. So DMA-DV is define, measure, analyze, design, and then verify. You would also hear something known as DMA-DOV, which is define, measure, analyze, design, optimize, and then verify. So generally this methodology is for a new process when you're trying to design, trying to come up with a new design of a product, or when you're trying to design a new process altogether. You would apply DMA-DV or DFSS. Otherwise, for a process which is already existing, you would do DMA-IC. Okay, any question up till now?
No, I think I'm good through now.
Okay, perfect. So the keyboard never works. Okay, how do we identify the projects? So there's something known as COPQ, which is cost of poor quality. So generally, so there's a diagram that you see here. So there's lot of hidden quality cost that you generally don't see unless until you would get into the data. And the general cost that you would generally see would be the rejects, the scrap, the rework, the warranty failures, or the inspection or the verification failures that you get. So if you look at the one here, if you actually assess this, you might be able to find a lot of factors which are generally the hidden, generally in this quadrant of hidden quality cost. All the lost sale, what is the reason why you're losing sales? Customer satisfaction level, overtime, so sometimes just to deliver the product to the customer, within the given timeline, we generally get the employees to do a lot of overtime. Why it is happening? Because somewhere in the process we are not able to, either our estimations are incorrect, or our processes are taking longer time than it should have, because of which it is leading to the work not getting completed in time. Any excess inventory that we have, late transition of the processes. So all these are the areas that you can actually dwell into to identify the reason for these reject, scrap, rework, or warranty issues. And all these would constitute to cost of poor quality. Some relation of COPQ and the sigma level. Again, this is not this is something that Michael Ajay Harry came out with when he launched Six Sigma concept. So what he said is, if your process working at a Six Sigma level, that would mean you are only creating 3.4 defect, and less than 1% of sale is the cost of poor quality that you have. Again, the table, just to explain the relationship between COQ, which is COPQ, cost of poor quality, with the sigma level and associated DPMO, defect per million opportunity. Various roles of Six Sigma in organization, and so Scott, it varies from organization to organization. So if you look here, there's something known as yellow belt, then you have a green belt, black belt, master black belt, and then a champion. So sometime you might find this role in the organization. In some organization, yellow belt might not be there. In some organization, they might also have white belt as well. So it is actually adopted from karate. So what happened is, it's a funny story. So Bill Smith was a great follower of karate. So when he came out with this methodology, he wanted to somewhere utilize the concept of belt that they have in karate into Six Sigma. So that's the reason why he came out with the concept of yellow belt, green belt, black belt, and then he did a master black belt. So in your organization, do we have a specified roles of Six Sigma? Do we have a Six Sigma team or certain black belts or green belts deployed in the organization?
I believe we have, I know we have some black belts, but I'm not sure how many master black belts we would have in the organization itself because it's so big. In my location, we have none of them.
Oh, okay.
I would be the only Six Sigma here.
Oh, perfect. Oh, perfect. So it's going to be easy route for you from green belt to MBB.
Mm-hmm. Sure.
Right. Great. So you don't have a yellow belt there?
We do not.
Okay. All right. So just to let you know, in some organization, they have a concept of yellow belt as well. And as I said, in some organization, they have a concept of white belt as well. So yellow belt is somebody who would have a basic understanding of Six Sigma. But then generally yellow belt would receive guidance from the GBs or the black belts. Green belt, again, green belt role differ from organization to organization. In one of the organizations that I was working in, when you're working in delivery or operations, you can be a green belt. So any project that you would do, you'd be considered a green belt project. In the other organization that I was working in, the green belt project or the role of green belt were defined. The project was defined as a green belt or a black belt project depending on the dollar value that the project has gained. So again, depend on organization to organization. There is no standard as such. So I will move ahead to a basic Six Sigma terminologies. So we have something known as defect, defective, unit, DPU, opportunity, DPMO, CTQ, USL, and LSL. I will flip through these slides. So we have, and we will begin with the define phase. Instead of going it through it in the slide, we will actually do a practical example and to understand all these concepts.
Okay.
And also I would suggest if you can go ahead and install Minitab on your machine. So if you go to the Google, you can see my entire screen, right?
Correct.
Okay. So if you go to Minitab, so you'll be taken to Minitab website, and you can actually install Minitab 18. It is not a freeware, so but they give you trial for 30 days. So what you can do is you can download the trial version, and you can practice it for 30 days. In case if you want to purchase the software, you can do that. Again, totally your wish. But then I would suggest before you appear for the exam, you do enough practice on Minitab so that you are able to understand the concepts. Since your organization do have some of the black belts, they might have a group license as well. So you would need to probably check within your organization when you actually do the projects if you have if you can utilize the group license of Minitab. Okay, but for training, if you can suggest the trial version, because we would be using Minitab in the later half of the training today and tomorrow.
Okay, I will see what I can do. I don't know if I have rights to download it on my machine, but I'll try. And if not, I'll get a hold of somebody that can update it.
Okay, all right. Okay. Oh, that's a official machine that you're using?
Yeah, I'm using a work machine.
Okay. All right, no problem. So let's understand the concept of BPMO. So what we need to understand are a few things: defect, unit, effective. Oh, so let's say we are an air conditioner manufacturing unit. Okay, and we manufacture air conditioner. So unit is the AC that we manufacture. Okay, so unit is the AC that we manufacture. Okay, and let's say we have a factory and we have manufactured 20 ACs. So every AC air conditioner have got 4 parts. Let's assume that the air conditioner would only have 4 components, which will be compressor, then you have condenser. What else would be there in the AC? You have coil. What else would be there, Scott?
The motor.
The motor. Okay. So let's say every AC have got these 4 parts. Okay, for the ease of calculation, let's assume there are only 4 parts in an AC. Okay, for every AC, so if we are trying to inspect an AC becomes a unit. Let's say we're inspecting one unit. So what are the various ways where it can go wrong? Either the compressor can be faulty, or the condenser can be faulty, or the coil can be faulty, or the motor can be faulty. So what basically we are saying, there are 4 ways in which AC can become defective. So if there is a defect in any of these, the entire unit will become defective, right?
Makes sense.
Right. So what we are saying, in every unit, so in every unit, how many opportunities are there?
4 opportunities to be a defect. Yeah.
Absolutely. So for every unit, there are 4 opportunities where the defect can be created. And if there is defect of any one of the unit or any one of the opportunity, entire unit would become defective. Right? Okay.
Sure.
So just a few concepts. So defect is anything which is not meeting the requirement. So if a motor has to function a certain way, if it doesn't function that way, or if it is not working, then it's a defect. So what we are doing is, we are producing 20 ACs. Every AC has got 4 opportunities for defect. So the total opportunity
80.
would be 20 multiplied by 4, which is going to be 80, right? Let's say out of 20 that we have produced, what we found out that, okay, forget the defective right now. What we found out that there were altogether 8 defects. Okay, the coil was not working 4 times and the motor was not working 4 times. Okay, now there are a few things that we want to calculate. So we have the data, we know the total number of units 20, opportunity per unit is 4, total opportunity is number of unit multiplied by opportunity per unit, and then we have the data on defect, which is 8. So we'll calculate 3 things. One is DPU, which is defect per unit, then DPO, defect per opportunity, then DPMO, which is DPO multiplied by 1 million. Okay, so let's calculate DPU first. So total number of defects that we got is 8. Right, Scott?
We have 8 defects, but is that per unit? Or is that 8? Are there more than 1 defects in a unit, or are we saying there's only 1 defect per unit? So we have.
Right, that is, so for this calculation of DPU, yeah, for this calculation of DPU, that is immaterial. So what we take for calculating DPU, we take total number of defects which have been there divided by total number of units, which are 20.
10%, yeah.
So this is 40% or 0.4.
Yep.
Right. So that's there. So there's a defect per unit figure. We don't do anything with this DPU. So DPU. So wherever we don't have 4 opportunity. Let's say we had only 1 opportunity. In that case, your DPU and DPO, there would not be any difference in that. Right, so let's calculate DPO, which is defect per opportunity. So there are 8 defects. How many opportunities are there altogether? 80 opportunities.
Right.
Okay, so it is generally called TOP. Defect by total opportunity. Is 0.1. Okay, so what we are saying is, every time there is an opportunity, we are creating 0.1 defect. Okay, so and DPMO calculation pretty simple. DPO multiplied by 1 million. So we have 100,000 is the DPMO. Right? So, so if you go back to the slides,